Hello, welcome back to another video. In this we are going to be continuing on with our volume. This is actually the last new lesson of volume. This is the entirety of the volume unit, so once you're done with this, you're done with the new material for volume. We're going to be having a test on volume. It will be next week, and then we will basically be done for the rest of the year. There's still maybe one or two things we'll do. We're still kind of figuring out some of the details as the news about when school is ending. Well, we're not going to give any new work after May 12th. So that will be when, like, we won't put any new stuff up after that. And all late work is going to be due on the 19th of May, and I'll send out emails about this as well as we get closer, but just thought I'd kind of let you know there. But we're almost done, and this is kind of the last real substantive lesson that we have before we're done this year, which is kind of crazy, right? And I hope you're doing well, staying safe. It's been a crazy year for all of us, I think. Um, so in this video, what we're going to be looking at is the volume of spheres. And spheres are, you probably know them by another name, but just a ball. Oh, there we go, a ball like this. Okay. We want to be able to find the volume of a sphere, a ball. How much space does this sphere take up? We want to be able to figure out what that is. Okay. And so we're going to use kind of the water again to help us figure out how does the sphere volume, how does it relate to the volume of the other shapes that we know. And so that's what we're going to do now is look at, kind of play around with some water and figure out how the sphere relates to the volumes we know. Okay, welcome back. So we're going to be finding the volume of a sphere, and then we'd like to make a formula for being able to do that, right? So I have a sphere here. Not sure if you can tell, but it's a nice little ball. Okay, got a sphere. And then I've got a cylinder. Okay, and you'll notice that this cylinder and this sphere, these are actually the same, they have the same circle as their base shape. And then they're also the same height. Okay, not sure if you can really tell from this angle, but they're the same height. Okay, also we have a cone here from last time. This was the same base and height of the cylinder, and so these two have the same base and height. Why I chose the cylinder and the cone are these are the two shapes that we've dealt with so far that have circles in them, right? So the sphere is kind of like a circle. It has a circle in the middle, and it's a really circular kind of shape. So I'm going to kind of use these to help us see what the volume of a sphere is. Okay. So what I'm going to do first is I'm going to compare the sphere to the cylinder, okay? Because cylinders are nice. I like those. So I'm going to, the cylinder is going to be bigger than this the sphere. So I'm going to pour some water into the sphere and fill it up and see how many times I can, or how many spheres can I fit inside of this this cylinder. Okay. Do another. Okay, there we go. So let's pour some more in. Ooh, I'm making a mess. Not sure if you can tell, but the cylinder now is full after one sphere and then a little bit more. The sphere still has more than a half. It's more than a half full. So it didn't go into it very nice, right? I put one whole sphere in there and then a part of another sphere, okay? And so this is not maybe the best comparison to do because our sphere, when we were pouring it into the cylinder, it didn't give us really a nice number of times that it went in. So what we're going to do is, instead of using the sphere to go into the cylinder, because that didn't really seem to work, was let's try the other shape that we have that has a circle in it, this cone, okay? And the cone, it looks like, is going to be smaller than the sphere. So I'm going to start pouring the cones into the sphere. Okay, and we'll see how many cones can go in the sphere. There's one cone. I've noticed with the cone, it's kind of hard to pour into other things. So I'm gonna, before I pour it into the sphere, I'm gonna pour what I have in the cone into the cylinder. Okay, the cylinder is a little bit easier to work with. Okay, so we now have that poured in. The one cone is in there. So let's put in another cone and see what happens. So again, I'm just going to pour this into the cylinder to make it a little bit easier to pour. Can you feel the excitement building? Okay. So the cylinder is now empty, and if you can tell, the sphere is completely full. Okay. So it took two cones with the same kind of circle base as the middle of the sphere. It took the same base as the middle of the sphere and the same height. It took two of those to fill up the sphere. So now that we know that, we're going to make an equation for the volume of a sphere. Okay. So we'll go ahead and switch to that. Okay, so if you remember, we just talked about two cones where the circle in the middle of the sphere and the circle on the bottom of the cone, when those were the same, and then the cone and the sphere had the same height, we figured out last time there were two cones that went into the sphere, right? There were two cones. So we had talked about before the volume of a cone. So let's just, we want to try and find the volume of a sphere using the volume of a cone. So what have we got here? Our sphere is like that, right? In the middle it has like a center. The center of the sphere is a circle, right? If you just cut it through the middle. And so it has a radius of that sphere. And you'll notice for a sphere, the radius is like kind of like the same as it is for a circle. It's just in 3 dimensions now. So it traces out a ball instead of just a circle. Okay. Then we've got our cone here. Okay. It had the same circle on the bottom. So that radius was the same. This radius down here was the same. Okay. And then we need to know the height of it to find the volume, right? So this was your height. Okay. Well, in this case, right, the height of this cone, we want to kind of rewrite that in terms of the radius of the sphere. Okay, so if you notice, the radius is also the same, like this distance from the center of the sphere out to the edge. Okay, that's the same as the radius, right? So both of those are the radius. As well, you could draw a line up from the center to the top of the sphere. This is also the radius. All three of these lengths are the radius length. Okay, so how many radiuses of the sphere are there in this height? Well, there's one here and then one here, right? So we've got two radiuses in the height. So the height is 2 times the radius in this case. Okay? In the case where we're having the cone have the same height as the sphere. Okay? Well, what was the formula for the volume of this cone? Well, it was 1/3 of the cylinder. So it was 1/3 pi r squared times h, right? This was the volume formula for your cone. Okay. So then, in our case, the cone we're dealing with has a height of 2r. So I can plug that in to the formula for h. I'm just going to replace h with 2r. Okay. And I'll simplify this a little bit. The r's are like terms. We can multiply those together. And the 2 and the 1/3 will maybe times together, so we get 2/3. 2 times 1 is 2/3. Or sorry, 2 times 1 is 2, and then divided by 3 is 2/3, right? And then pi r cubed. So we just moved these r's to be next to each other, which will make an r cubed, and then a 2 times a 1/3 is a 2/3. Okay? So the volume of this cylinder is, or sorry, not this cylinder, of this cone is 2/3 pi r cubed. Okay? So we take the radius of the sphere, and the volume of the cone will be 2/3 pi r cubed. So what's the volume of the sphere then? We had talked about 2 cones go into the sphere, right? So 2 cones go into the sphere. So the volume of the sphere well, we're going to take the volume of our cone, and then we're going to times it by 2. So we do 2 times 2/3 pi r cubed, right? Because there's 2 cones that go into this sphere. So I just take the volume of the cone and times it by 2. Well, what do we get when we simplify this? The 2 and the 2 times together to give us 4/3 pi r cubed. Okay? And this is the formula for the volume of a sphere. of radius r. Okay, so that's kind of cool. A lot of people, when they see this formula, they're like, where does the 4/3 come from? But essentially it's because the cone, right, is that the thirds is coming from, the cone is 1/3 of the cylinder, and then you've got really you've got 2 of the cones inside of the sphere, and then the height of this cone was 2 times the radius. So that's kind of where that's coming from here. Okay, now you don't need to be able to derive this formula, but I wanted to show you where it comes from so that it's hopefully not as weird. Okay, so let's look at some examples of using it. Okay. Oh, wrong examples. Okay, here we go. So, to find the volume of the sphere, we use this formula right here, 4/3 pi r cubed. And so on this one, the radius is 5. So the volume of this cube is going to be, you just plug in r. So 4/3 pi times r cubed, which in our case r is 5. 5 cubed. And then we just throw that in the calculator. You know? Okay, so we've got 523.598, so I'll just do 523.6. This would be cubic miles. That's a pretty big ball. Okay. Similar thing for this next one, it's just the radius is 10, right? So we plug in 10 for the radius and then throw that in the calculator. You notice spheres are really nice because there's only really one measurement you have to worry about, and that's the radius. Okay. So this is 4,188, and I'm going to do, it's 0.79, but I'll round it up to 0.8. So that's kilometers cubed. Okay. Lastly is the sphere, and you'll notice it's telling me 4 is how long this is, this whole thing across. Now, is that the radius of the sphere? No, the radius goes from the center, so this part here, that's the radius, okay? So this is the diameter of the center of this circle, kind of the center circle that you get there. So the radius of the sphere is actually 2, right? It's half of what the diameter is. Okay, so you need to be careful. You can't just plug the number in that it gives you. You need to make sure, is the number it gives you actually the radius? Because that's what goes into the equation. So we found the radius in this case was 2, so that's what I plug into this formula. Okay, so I do 4/3 pi times 2 cubed. And we get 33.51, so I'll just leave it as 33.5 kilometers cubed. Okay, so finding the volume of spheres is a little more complicated than cones and pyramids, but really the actual computation of it, the formula is quite simple. You only need to know the radius of the sphere, and you just plug it in to find the volume of your sphere. Okay, so hopefully that's helpful. Go ahead and do the homework and then take the quiz, and I will see you guys later.